Once again, good morning to one and all present here in today's lecture. See, in the last session, actually, we discussed about introduction to thermodynamics. In today's lecture, we are going to discuss about basics and terminology of thermodynamics. And what are the terms actually we are having in the thermodynamics? And what about the basic concept actually we are having in the thermodynamics? That is what actually we are going to discuss in the today's lecture. So, myself, Arun Kumar K, Assistant Professor, Aeronautical Department, MLR Institute of Technology, Hyderabad. So, we will enter into the today's session. The first basic of thermodynamics is nothing but actually we supposed to know what is meant by system. See, in the previous lecture actually we discussed about we are going to do the performance evaluation of a system, right, with respect to energy level transfer and with respect to energy level capacity, right. So, for that actually we supposed to understand what is meant by system and what kind of actually classification we are having with respect to the system, right. See, what is first of all meant by system? With a simple definition we will come to know. The part of the universe, right, that is under consideration, which is separated from the rest of the universe by its boundaries. Got it? So, the universe here in the sense actually we call it as always systems, boundaries plus surroundings. This we call it as universe, right. See, for example, I'm having three kind of systems over here. I'll consider the closed system over here. See, I can able to consider the closed system over here. With respect to this system actually, inside I'm having a certain quantity of matter, right. It might be oxygen or it might be air we can take, or air plus fuel mixture also we can take. So, this is what actually we call it as actually system, right. So, this system is covered by actually wall, that is nothing but we call it as in technical term boundaries, right. Apart from that actually, see, inside we are having is nothing but actually system, and this is nothing but actually we call it as boundaries, right. And see, the surroundings actually we are having with respect to the boundaries, so which is actually separated from the system, right. So, that is what actually we call it as universe, entire universe. Got it? So, this is the simple definition of system we are having, right. See, in that actually what kind of systems actually we are having? Based upon energy and mass transfer actually we are having three categories. One is nothing but we call it as open system, and another one closed system, and another one, last one, isolated system. See, in that open system, when matter can cross the boundary, right, when matter can cross the boundary, then we can able to say that is nothing but we call it as open system, right. So, wherever the flow of matter is happening, then I can able to consider that as open system. That is what we mentioned over there. See, actually we are having in the open system, when matter can cross the boundary, then we can able to call it as actually open system. Then what about the energy level? So, energy level actually with respect to the boundary, it always will transfer from one system to another, or we can say system to the surrounding, right. So, here actually for the open system, matter also transfers as well as energy, heat also transfer, right. Then closed system, right. So, here actually in the closed system, only energy level can able to transfer, right. The matter is always constant throughout the process. That is actually we call it as a closed system. See, in this system actually I can able to transfer only the energy in terms of heat actually we are going to discuss. That is what actually we have mentioned as heat. But see, the matter can't transfer with respect to the closed system, which means the mass of the substance, right, the certain quantity of the matter inside the system is always constant. Then we call it as actually closed system, right. See, this actually in general we call it as non-flow systems, right. But open system is nothing but actually we call it as we can consider with respect to flow system, right. So, that is what actually two differences actually we are having based upon matter transfer as well as heat transfer, or we can say energy transfer, right. Then third one is nothing but we call it as isolated system. See, in that isolated actually you can able to see this isolated system, thick boundaries actually we have drawn, right. We can able to say with respect to with respect to some example, actually I can explain. See, listen here. This actually thermoflask actually we are having in our day-to-day life. And thermoflask is nothing but actually we are having the isolation chamber. Inside that actually we can able to maintain more amount of energy, right? More amount of heat inside, right? So that is what actually we call it as isolated system. Here actually boundary seals, which means no matter can transfer and neither heat also transfer. That is what actually we call it as isolated system. This is isolate from the surrounding. Got it? Right? So these are all actually basics of thermodynamics, we call it as. With that only we can able to consider the system. Right? See, after that, based upon actually with respect to the phases of matter, we can able to classify into two types. One is nothing but we call it as homogeneous system, and another one is nothing but heterogeneous system, right? So this is purely based upon the phases. So everyone knows that actually in general for all substances exist with respect to either solid phase, liquid phase or gaseous phase. So these three phases actually we are having, right? See, a system consisting of a single phase, then we can able to say this is nothing but a homogeneous system, right? See, single phase is nothing but actually either a solid phase actually we supposed to consider, or liquid phase we supposed to consider, or gas phase we supposed to consider, right? In previous lecture actually we discussed about steam power plant. In that actually we consider majorly four component. One is nothing but boiler, right? Inside boiler actually we have taken the liquid, right? While I'm adding the heat energy, what happen actually that liquid is converted into a form of vapor, high pressurized vapor, right? So which means, see, water is converted into, water is nothing but liquid phase we are having, liquid phase is converted into gas or vapor phase, right? Okay, now if I'm having only with respect to the single phase, then I can able to say that is nothing but homogeneous. Homo is nothing but everyone knows same, right? Then a system consisting of more than one phases, right? One phase is known as heterogeneous system. What is that more than one phase? Actually, the combination of solid plus liquid, right? S is nothing but solid, L is nothing but liquid, or we can say liquid plus gas or vapor, whatever it may be, right? I said boiler. Boiler we can able to consider with respect to liquid plus gas. So that comes under actually we call it as multi-phase, which means it comes under heterogeneous system, right? So based upon this quantity of matter also we can able to classify. See, in the previous slide actually we discussed about based upon matter as well as heat transfer we classified, right? So these major two classifications actually we are having according to our syllabus, right? Right. So in the previous slide actually we have discussed about what is meant by system and what are the categories of system we are having, right? That how to picking a system, right? So for that actually we are having it based upon the investigator. It based upon the which part actually we took for the analysis, right? So based upon that actually I can able to picking a system. Got it? See, in the steam power plant actually I can go with a simple example. In steam power plant I said what are the four major components we are having. Boiler we are having, after the turbine, then condenser, and after that pump, then cycle ends, right? So like that actually we are having the four major components we are having. See, with respect to that actually if I want to analyze the complete steam power plant, then my system would be with respect to the all four major components. Got it? I supposed to consider the inlet condition of boiler, right? Outlet condition of the boiler. Same applicable to the other components also. In that way I supposed to pick the system, right? So it based upon the purely based upon the investigator picks the system. Got it? Only I need to bother about what kind of outlet conditions actually we are having with respect to the boiler, which means only the boiler component we can consider, right? Then my system is nothing but the boiler, separate boiler. Got it? So in that way actually I supposed to pick the system. Got it? See, that is what actually is mentioned. It can be as large or as small as that. It depends upon what we want, right? What we are going to consider, right? So that is what actually we have mentioned over here. See, it can be as large or as small as you want it to be, right? Proper definition of the system is important to address the reaction what you want to, right? So with respect to us or with respect to investigator, we can able to picking a system, right? See, leaving out gases or sediments or melts or other can make a problem simpler and tractable or more inaccurate, right? So which things actually I want to do the analysis, whether leaving out gases or sediments or melts or other process also I can able to consider, other problems also I can able to consider. In this way actually I need to pick the system. Got it? See here, actually I'll go with the example. This is the boiler actually we are having, the steam power plant, and after that it is connected with the turbine, and then after that actually we are having a condenser. See, in the condenser actually I'm having the heat exchanger, right? And after that we are having a pump, right? Then again it joins with respect to the cycle, right? See, this is actually we are having boiler, and this is turbine, steam turbine, and this is condenser, and this is pump, right? So this is the major 4 component I am having. See, if I want to pick the system as a steam power plant, then I supposed to pick the complete all 4 components, right? Only I need to bother about with respect to the boiler inlet and outlet, then I supposed to consider only the boiler as the system. Got it? So like that actually we can able to apply for the other components also. So in this way actually I can able to picking a system, right? Now I have picked the system, right? And in which way actually I supposed to defining a system, with respect to which thermodynamic properties I supposed to define the system, right? For that actually I supposed to know with respect to the equilibrium conditions, right? So after that actually we will discuss about the terminology. Listen here. So for defining a system at equilibrium has measurable properties, right? Measurable thermodynamic properties. What are the thermodynamic properties actually we are having? We are having pressure, temperature, volume, right? So these are all comes under thermodynamic properties. In order to measure that actually, see, inside the boiler I am having, again I will consider the boiler over here. See, in the boiler, if I am having the pressure gauge over here, after the heat addition process, see, during heat addition process it keep on changes. This pressure gauge keep on changes. That indicator won't shows the particular value, right? But after completion of the process, what will happen actually? It stops for a while, right? It shows the particular value for a while, that we can able to consider as, right, attains the equilibrium conditions. Then I can able to measure that properties. Until we can't able to measure the property, it is keep on changing. That is why I include a term equilibrium condition. Once the system attains the equilibrium, then I can able to measure the thermodynamic properties, right? Then I can able to define the particular system. Got it? So like that actually I can able to define the system. For example, see, if the system changes from one equilibrium state to another, right? These changes depends on the properties changed and not on the path, right? Or we can say that is the exact process that we will see, right? The changes went along. Got it? See, this 2 graph actually I have mentioned over here. With respect to this, assume this is the initial condition and this is the final condition. With respect to initial I, final F, right? So this is what actually we can able to measure the properties with respect to. See here, in this y-axis, I have mentioned the energy level, right? So we can able to consider the thermodynamic properties also. We can go with the temperature or whatever it may be. Got it? So with that actually I can able to sense this measurable properties once it attains the equilibrium condition, right? Then I can able to define the system, right? So after defining the system, right? After defining the system actually how to measure the properties, for that actually I need to know this terminologies. That is what actually we are going to discuss right now. See, the first basic terminology is nothing but, see, after attaining the equilibrium condition, then we can able to say that it attains some state, right? In the previous slide I said initial state and final state. Assume some heat addition process is there, right? You will take some heat addition process. See, I am having the vessel over here. I am adding the heat energy infinitely slow manner, right? So what is it actually before heat addition process? That is nothing but actually I am having inside. Assume we are having water. We are having, assume that, right? So in order to measure these thermodynamic property, assume we are having the thermometer over here. in order to sense the temperature, right? See, before heat addition actually it shows some particular temperature, right? Say for example 25 degrees Celsius. That 25 degrees Celsius is constant, right, before the heat addition process. Once the heat addition process completed, then we can say it reaches up to how much? 50 degrees Celsius, right? It shows 50 degrees Celsius for a while, right? Then I can able to say it attains the equilibrium conditions. Then I can able to measure this particular properties, thermodynamic properties, that we call it as actually in technical term state, right? See, state is nothing but actually refers to the energy content of a given system, right? So it always represents with respect to the energy content of the given system, right? So the state is defined by specifying certain variables, right? Variables, or we can say properties also we can consider, right? So these are the varying properties actually we are having inside the system. What is it actually? Such as temperature, pressure, volume, and its composition, right? This composition actually applicable for chemical engineering. For thermodynamics actually we supposed to consider these three one. Got it? So with respect to these variables, temperature shows actually particular value, so which means it reaches the equilibrium condition. Then I can able to say it attains the state, right? See, if I am having the measurable properties, then I can able to say that is nothing but state, like initial state and final state. In between also we are having intermediate states, right? With it also I can able to specify that, right? See, the state variables specifically refer to the change inherent if a reaction proceeds because of change in state. Got it? Okay, na? So the state variables is nothing but actually what is that? Temperature, pressure, and volume. This actually refers to the change inherent if reaction proceeds because of a change in state. Got it? Right? So in order to mention these variables actually it's supposed to attain equilibrium condition. What is that actually? The measurable quantity, measurable properties. Got it? Right. So that actually I can able to find out. So it belongs to this state, right? Okay, na? We can able to say in simple term, I can able to measure the coordinates, right? Assume this is actually we are having PV diagram, right? You have studied in intermediate level PV, pressure and volume. That actually before starting the process, assume this is initial 1, right? In that actually I am having what are the coordinates? P1 comma V1. That is what actually we are trying to say. Got it? Right. Next, P2, V2. Like that actually we can able to identify the coordinates. That is what actually we call it as states over here. Right. Then, see, after defining the state actually we supposed to enter into process. Right. So once I know the initial and the final state, after that actually I can able to find out this belongs to which process. Right. For that actually I supposed to find out the way or path. Right. The way, or we can say the path, the way a system changes states, right? That actually I can able to say this is actually leads to process. Got it? See, in that PV diagram I said again, in that PV diagram we are having one is nothing but P1 V1 and another one is nothing but P2 V2, right? P2 V2, this is P1 V1, right? That is what actually coordinates we are having. Right. With respect to these two states actually we can't able to find out this belongs to which process, right? It may able to reach linearly, right? Or it may reach with respect to curvilinear. Got it? So that path or way we supposed to consider, right? We supposed to evaluate. Then I can able to sense the process. Got it? Right? So that is what are the various process actually we are having. Simply we are having, you have studied in your intermediate level adiabatic process, and after that isobaric process, right? For isobaric in the sense we know that, see, simply we can say isobar in the sense constant pressure in the sense, see, P1 equal to P2, that is a constant pressure. For that if I want to draw the PV diagram, see, P1 equal to P2, I supposed to draw the horizontal line, then only this 1 and this is 2, then I have found out the path, right? In between 1 and 2, see, in between 1 and 2 I have found out the path. Then I can able to say this process belongs to isobaric. Got it? So like that actually I supposed to find out the process, right? So first I need to evaluate the state, and after that the path, then I can able to evaluate the process, right? Then once I evaluated the process, then I can able to go with respect to the cycle, right? The combination of two and more processes is nothing but actually we call it as a thermodynamic cycle. In the thermodynamic cycle, the final process, final state must be equal to the, right, the initial process, initial state, right? So then I can able to say it follows the thermodynamic cycle, right? So these are all terminology of what we can say thermodynamics, right? So first one is state. Now to sense the state, see, listen here. That is what actually we have given in terms of the points. See, the properties we have evaluated. Once the properties evaluated, then after that I'll underline that path. Once I have the path, then I can able to find out the process. Once I found out the process, then I can able to lead to the thermodynamic cycle, right? See, that is what actually we have mentioned in this. We can say this is nothing but actually whatever we discussed in the previous slide. That is actually we are having a summary over here. Got it? See, listen here. Every system has certain characteristics by which its physical condition may be described, right? Described is in the sense actually it is a measurable one. Example is nothing but volume, temperature, pressure and etc. Right? Density also we can go and other composition we said, right? Such characteristics are called properties of the system. Once I know the properties, then the coordinates to describe the state of a system. Once I know P1, V1 and T1, with that I can able to describe the state of the system. Got it? Once I know the state of the system, then the succession of states passed through during a change of state is called the path, right? With respect to the successive changes actually, how it changes, then I can able to find out the path. When the path is completely specified, right, then the change of state is called is nothing but process. If path is specified, then I can able to find out the process. See, 1 and 2, right, 1 and 2, these are actually we are having state. In that actually we are having coordinates P1, V1 and T1. Here P2, V2 and T2. Got it? Then 1 to 2, the path also I have found out. This is the process. After that, see, once we found out the process, the combination of more process that leads to the cycle, right? Which means, see, I'll consider 1 to 2, after that 2 to 3, then see 3 to 1 again, right? It reaches the cycle. So in this way it repeats, right? So like that actually I can able to find out the thermodynamic cycle. See here, the thermodynamic cycle is nothing but defined as a series of state change that the final state is identical with the initial state, right? What is the final one? Actually 3 to 1, right? 3 to 1 in the sense actually 3 to 1 the final state is nothing but actually again reaches the initial state, right? Got it? Okay, now like that actually we need to sense the terminologies, right? So in order to sense the terminology, first actually we need the physical properties. Got it? Right. So with that actually we'll end the session today. Next lecture actually we'll discuss about leads to the terminology of thermodynamics, right? And after that, what are the various laws of thermodynamics actually we are having. That we'll discuss in the next lecture. Thank you very much.